Hello, my name is Ken Corey. I've worked on the Android version of the wallet app at Santander for about a year now. During that time, I've faced a few challenges, but 4 specific ones stick out. As all good engineers know, the best way to fix bad code is by writing more code, right? And that's why I've designed the Circus architecture. I hear you saying, why another architecture? Well, these 4 reasons were my main motivation. TDD, our current architecture, which is MVP, encourages our code to be tightly coupled and our tests to run slow, up to 10 seconds per test. As for threading, I've never had a boss come to me and say, our app needs more multi-threading. They say, our app needs to run right. Now, I don't want to bother with something my boss isn't paying me for, so let's allow the framework to do the threading for us. Development is slow precisely because our tight coupling makes it hard for multiple people to work on the same feature at the same time. And finally, wouldn't it be great to be able to record the user input and play it back with millisecond accuracy? Or play back the UI events to show usage, as in for a tutorial, but without having to ship movies. And when I said Circus architecture, did you think clowns and elephants? I'm sorry, that's not what I meant. Think Piccadilly, not Ringling Brothers. Events move from the front to the back. States move from the back to the front. A word on the nomenclature here. When I say front, it's the activity or view that you can see on the phone. When I say back, it's the logic that on the phone that makes that activity change. If I mean web server, I'll say server. Now this is the landscape of an app written with the Circus architecture in mind. We have activities on the left, which inherit from the Circus activity, which gives them just a little bit of magic. Let's say the white activity on the left is a login page with a green login button on it. When the user presses the button, the press is turned into an event. That is sent to the Circus activity on the UI thread, shunted to a new background thread, and delivered to the back class. Note that the back class in the activity did not know where the event was going to or where it came from. The activity and the back class are completely separated. They haven't even been formally introduced yet. The back class is owned by the Circus, and the Circus by the app. If the activity goes away for some reason, the logic and the state remain behind, waiting for the next activity to wake up. The back class and the Circus are written in just Java. They don't know anything about contexts, activities, broadcast receivers, or any other Android construct. This makes the test run about 800 times faster than an espresso test. We could run every single test for the whole of the logic of our app in about 2 seconds, without any fancy mocking or structural testing framework. The back class realizes that we're going to be making a network call here, so it wants to show a busy screen to the user. A new state is constructed and sent to the Circus activity, which moves the state onto the UI thread and then delivers it to the activity where it is rendered. We have now told the user we're about to do something that takes some time. Any code that runs in the back class is, by default, on a new background thread. It won't block. Any code running in the activity class is, by default, in the UI thread. We don't have any threading management needed at all. Now it's worth talking about the events and the states a bit. Events and states are simply POJOs, plain old Java objects. They are therefore easily serializable and could be written to disk. If they're written with a timestamp, we could play them back with millisecond accuracy. There's a fair chance that most of the bugs that we would normally say, whoops, well, we can't reproduce that, they'll become reproducible now and we can fix them. So let's go back to our user who now has a busy screen, but still wants to log in. Now I have said the back class is just Java. If that's the case, how does it make a network call from an Android phone? Well, by using plugins. Plugins wrap the things that you generally create as a singleton, or that would use the application context. Network modules, databases, etc. Things that change our global state. Again, the work they're doing is still on that new background thread, which means the UI still doesn't block. The code back there can block and nobody should notice. So the back class calls a well-defined API on the network module to log the user in, The result of the network call is returned to the back class as an event. The back class already knows how to deal with events, so we didn't need any more code. This is just another event. The back class creates a state to reflect the new state of the application, forwards it to the Circus activity, which delivers it to the login screen, which now tells the user, hey, congratulations, you're logged in. That's really the basic functionality of the Circus architecture. It's pretty simple, really. TDD is now easy and fast. We can get between our components very simply. You could assign a developer to the activity, another to the back, another to the network module, and so on, greatly speeding up your development. And finally, you could see how we could record either incoming events for testing or outgoing events for playing back the UI states. But there's more that this architecture offers. The way we currently deliver software bundles all the parts of the app together and puts the lot into the App Store. We are sending innocent code into harm's way. If Mr. Badman were to download the app and decompile it, he'd get obfuscated versions of not only the code for our activities, but also the logic, the backend, the methodology, any keys we've got in our app, our strings, etc. It even shows Mr. Badman how to access the API of our website and accomplish things. While Mr. Badman is decompiling our app and learning our secrets, our app can't call for help as it's not even running. No matter how hard we try to obfuscate code, eventually it will be broken by Mr. Badman if he's determined enough. So it's simply a matter of time until our app is cracked wide open. But that got me to thinking, what if the parts of the app were separated? In this model, the activities would be bundled with a slim proxy that forwards events to the server and returns states to the activity. If Mr. Badman were to decompile this code, what would he get? The ability to draw states on the screen and the ability to send us button press events. Try as he might, this won't expose our secrets, our logic, the real API to our web server, etc. Now, to be sure, websites get hacked all the time too, but at least there we have a fighting chance of knowing when our website is being hacked. Obviously, this is only going to be applicable in instances where the user is assumed to have connectivity at all times, like a banking app. There's also the outside chance that if we could deliver a slim front end for Android, why not deliver a similarly slim front end for iOS using the same logic? What about Windows and Mac? And what about a text-based UI? We could do it on an embedded system as well, all from the same logic. There are other benefits too, but this is getting a bit long now, so I'll close. That's my introduction to the Circus architecture. If you have any questions,